Hello, everyone. Welcome. It's so nice to have so many of you here today. It's a great turnout. Very nice to see. I'm Elske de Groot. I'm the marketing manager with 2G Energy. And joining me today, we're going to have Brad Pleima. He's the senior engineer from EcoEngineers. Jon Going, who's the regional sales manager at 2G Energy. Werner, he's a managing partner at Renewable Organics Management, and Jeff VanVoorhis, vice president at Symbiont Engineering. Also joining us for the Q&A is going to be Kurt West. He's the vice president of business development at 2G Energy, and he'll be facilitating any of the questions that you have that you can type in. So today's webinar is going to have 5 different parts. Brad is going to start. He's going to talk about the basics of the California LCFS program and CI scores. Jon is next. He's going to talk about the CHP solutions for CI score reductions. And then Ethan will be up. Ethan's going to talk about utilizing the CHP generation for farm-based biogas systems. And then Jeff is going to follow up at the end and talk about EPC development of RNG projects. And then right after that, we're going to have the Q&A session, which Kurt will moderate. So there's just 2 housekeeping notes. First one is you can use the question box to type in your questions for the Q&A at the end. And also the screen where you see me on right now, you'll see other speakers when they come to speak as well. You can minimize that screen if it's covering the slides too much, so you can drag the corner, or you can even exit out completely if that's what you want to do. Looking forward to this webinar. We have wonderful speakers. They're all very knowledgeable, and I'm sure you're going to learn a lot today. So, Brad, are you almost ready? I think I have to send Brad. Yes, I do. Have to send him a, where is it? There we go, Brad. Thank you. He did it for me.
All right. I feel like that's like the walk up to the stage now, huh?
Yes, it definitely is. Yeah.
No, great. Thanks, Elske. Really looking forward to talking with everyone today. I have the easy job. I get to talk about the basics and what LCFS is, what carbon intensity scoring is, and then I'll just run through a quick example of what are some typical CI score ranges for RNG projects, and then get in a little bit more into the details of, in a case study, just a generic 4,000 head dairy farm. What do the economics look like? And then what is the impact of analyzing, CHP, and what's the direct monetary benefit towards CI reduction? So next slide, please, Elske. So just a quick, little bit about EcoEngineers if you're not familiar. Like I said, my name is Brad Pleima. I lead the renewable natural gas line of business, and we're renewable energy consultants, and a lot of our work is in biofuels, specifically the Renewable Fuel Standard, the RFS, and the California Low Carbon Fuel Standard, and other emerging markets like Oregon, British Columbia, Canada LCFS type program. And as more and more of these state-specific programs come online, there's going to be more and more attention paid to lower carbon fuels specifically. And so what we do is you can see the 6 service areas that we focus in here. Specifically, a big area that we do is life cycle analysis, carbon intensity modeling under the California, Oregon, or the British Columbia program. We've done, I think, pushing almost 300 life cycle analysis, CI assessments for various biofuel projects, and have a good path into the California LCFS, and submitting over 200 LCFS pathways. So with that, on the next slide, we'll just touch base on what is the California LCFS program. Low Carbon Fuel Standard, the goal is to reduce greenhouse gas emissions by 20% by 2030. This program started a little more than a decade ago and actually had an original goal of 10% reduction by 2020. And the program was very, very successful and is very successful. And the state of California decided to really double down on those goals and push that out to 2030 by 20%. And actually, there's ongoing talks right now in their recent rulemaking process is, what will the next version of the LCFS look like? Will they continue? Will they increase the goal? Will they push that out to a 30%, 40%, 50% reduction by 2040? And we'll see where that develops. But it really has been a model program for other states and other countries to mirror, because it's done exactly what it is intended to do. It's lowered, it's incentivized the development of low carbon fuels, and it's lowered the overall carbon intensity of fuel that's consumed within the state of California. So one thing with RNG, renewable natural gas, a lot of those projects have taken advantage of and are participating in the California Low Carbon Fuel Standard. The standard is a fuel neutral, so it does not treat RNG any different than hydrogen, ethanol. The processes are the same. The carbon intensity scores are different, but the overall processes are the same. And the key here, it's a performance-based system. So the more efficient and the lower carbon intensity that your fuel is going into the state of California and the LCFS, the more credits and therefore the more revenue you're going to see from this project. So really what it's done is it's incentivized not only the development of projects, but once projects are operational, you really want to do whatever you can to lower the carbon intensity of the fuel that you're producing, because as I said, there's a direct monetary benefit by doing this. The Oregon Clean Fuels Program, just to touch on that, is almost a mirrored program compared to the LCFS. Some slight differences that Oregon enacted to make it a little bit more focused on Oregon, but there's also the state of Washington just recently passed a similar type of a program, and New Mexico, New York, Massachusetts, many other states are looking at a low carbon fuel standard. So we're going to focus on California today because it's the most established and the credit values are the highest of any of those. But know that a lot of these principles can apply to these new emerging markets like Washington and other states. Next slide, please. So how does a LCFS credit get generated? Taking it back from RNG. If you're developing an RNG project, really anywhere in the country that's connected to the natural gas pipeline system, you can inject RNG into that grid and then have a contractual pathway with somebody that's dispensing compressed natural gas as a vehicle fuel in California. And that contractual pathway allows you to sell that RNG, even though we know the molecules will never, in most cases, never physically get to California. What's happening is, because we're all connected to the same natural gas grid, that principle of book and claim or displacement is what's used for RNG projects to participate. So you produce, we're in Des Moines, Iowa, you produce, inject gas in Des Moines, you can have an equivalent contract to dispense an equivalent amount of CNG in California, and tying that together completes that entire pathway, and you're able to register for a pathway under the California LCFS once you demonstrate that the fuel is produced and consumed within California. Then the LCFS credits are actually generated once a quarter, again based on how much RNG was produced and injected into the natural gas system, and then how much ultimately was dispensed as a vehicle fuel. Those credits get generated, and then they're sold to regulated parties. And really, a regulated party is anyone that has title to fuel that is entering the state of California. And if you are dispensing or have title to fuel that petroleum-based fuel, then you'll actually generate deficits under the program. And if you're generating lower carbon fuels, you'll generate credits. And those who have this obligation that CARB puts in the California Air Resources Board, year over year, the people with deficits need to go buy credits from the people generating credits. So this system it's not a tax incentive, it's not a tax credit, it's an actual obligation under the California Low Carbon Fuel Standard And the dollars that are changing hands are from those regulated parties that are dispensing petroleum or higher CI-based fuel. Next slide, please. So what is carbon intensity? You hear that often. It's really a life cycle of what is the overall inputs and outputs of this fuel production. So it takes into account the feedstock and transportation. What feedstock are you using? How are you getting it in, say to a digester facility in an RNG example? And then at the RNG production facility, how much electricity, how much natural gas, and then what's the carbon intensity of that process energy that you're using? And I know some of the other speakers are going to talk about how to reduce the dependence on grid electricity and grid natural gas, which is a contributor to making the CI score worse in many of these projects. So using something like renewable energy, CHP, using something to lower the overall carbon intensity of the energy that's being consumed to make the fuel, in this case, renewable natural gas, can benefit the carbon intensity score of that fuel. Ultimately, we're talking here about transportation fuel, and that's what the CI is related to. What is this entire life cycle and the carbon intensity and inputs into producing that transportation fuel? And then what does it take to transport that fuel and combust it in an engine? So you'll often hear the term well to wheels, and that's really just a way to say every step along the process and the inputs it takes to create, transport, and combust that fuel as vehicle fuel goes into this carbon intensity score. Next slide, please. So what are some potential carbon intensity score ranges? I notice a lot of times we'll talk about these CI scores as unitless, but the unit is really grams of CO2 equivalent per megajoule. But oftentimes you'll hear I'm minus 200 or plus 40. So in this case, just some general ranges for RNG projects. Landfill gas, typically positive 30 to positive 60 CI score. Wastewater plants, a little bit better than that. And then when you start talking about some food waste projects, where if you're diverting that food waste from landfill, you can actually get into the negative carbon intensity scores. And then the big one in RNG right now, a lot of people looking at dairy and swine manure because these have highly negative carbon intensity scores. And what's driving the development of these are these LCFS credits and also RINs under the RFS program. So you can see the example over to the right. What's so great about dairy and why are there so many projects being developed in the dairy industry is because you can see when you produce a MMBTU of RNG from dairy manure, you can see the value of the commodity, $2 or give or take. But then you look at the D3 RINs that are possible, $37 just from the federal RFS RIN credits. And then when you stack on top of that the LCFS credits, you can see another $65 an MMBTU with a carbon intensity score of negative 225. And that's where as that carbon intensity score gets lower and lower, the value and that revenue associated with that RNG becomes greater and greater. And that's really the push to improve carbon intensity scores, is to capture more of that LCFS revenue. So you can see $100, over $100 in this example per MMBTU for a commodity that has a molecule value of just over $2. And that's really what's driving the development within this RNG industry, specifically at a lot of agricultural facilities. We also see a lot of development in the food waste, wastewater treatment plant, and even landfills. All of those can take advantage of these programs, although with those higher or worse carbon intensity scores, the revenue is not as substantial as a dairy that's shown in this example. Next slide, please. So here's just a breakdown of a dairy project. I know there's a lot of text and a lot of numbers on here, but really just wanted to show on the left-hand side, you'll see the various contributors to carbon intensity scoring. So in this is a dairy example, you can see manure handling. The ones we're going to focus on: grid electricity for the digester and biogas upgrading use, 25 CI points that are attributed to using grid electricity for this example. Another 14 points or so for using natural gas to heat the digester and to power a thermal oxidizer. So you can see there, when you look at all these user controlled fields, those are far and away the biggest factors that you have somewhat control over in these RNG in this dairy example. And then you see some fugitive emissions that are going to happen through the process. That's almost a fixed value. You have pipeline transmission to California. So we know these will never physically make its way to California, but you still have to take into account the transport, basically the distance to California. And then we see the CNG dispensing and combustion as vehicle fuel. And then the big negative number are the avoided emissions from the dairy farm. So really what these projects are getting credit for, a lot of these dairies are putting manure into an open lagoon, and that lagoon is getting into anaerobic digestion conditions and emitting methane, and that's a big area harm to the atmosphere, and you're getting credit under the California LCFS by stopping doing that. So you can see some of the negative CIs in some of these various scenarios here, but I think the big focus is 40 points that are there from grid electricity and grid natural gas, and installing things like CHP and other ways to reduce the dependency on those grid and those fossil sources can improve carbon intensity scores for these types of projects. Next slide, please. And just to, here's a couple of dairy and swine manure considerations. What matters when you go into the CI? It is the baseline, manure management practices. Is there a solid separation? Basically, the more manure and the more volatile solids going to the lagoon, the better the potential for the carbon intensity score is. And then as we showed on the last, you layer in the project, the RNG project, the digester, the biogas upgrading system, taking a look at yield, how you're handling digestate treatment. All of those factors will go into establishing what an RNG facility's carbon intensity score is. Next slide. And just to wrap up here before I hand it off, here's just a general overview that kind of ties everything together. You do need to apply for a pathway into the California LCFS program. You can do that once you have 90 days of operational data. So there's really no pre-application. The facility does need to be operational. You get that pathway validated by a third party, and then that pathway becomes certified, and you can use that pathway to generate credits on. And as I mentioned, you'll do that quarterly. The credits are issued, and there's annual reporting obligations, and there is an annual verification requirement just to make sure that everything is being done properly and the credits that are being generated are valid. Next slide, please. And finally, just to tie all this together, what are we talking about overall dollars and of economics here? You can see if we look at a 4,000 head dairy, this is a very general example, 15 million in CapEx, give or take, $1 million in OpEx. That can produce, maybe somewhere around 250 SCFM of biogas or 200 MMBTUs per day of RNG. And if we make an assumption that a carbon intensity score is minus 250, then you can see over here on the right some of those economics that we talked about. The gross natural gas revenue, the D3 RIN revenue, and then the larger one, the California LCFS revenue. You can see here the California LCFS credit is $185 a metric ton, give or take right now. Very significant incentives to do this. You do have some offtake expenses, some O&M expenses of the facility, but you can see here an EBITDA number, a little over $4 million from this 4,000 head dairy against a $15 million CapEx. So a sub 4-year payback in this example, in this generic example. But wanted to point out here is if you look at the CI reduction, if you're able to improve that carbon intensity score, every 10 points adds an additional $2 per MMBTU, maybe just a little bit more at current market value, but $2 is a good rule of thumb there. So if you're able to reduce the, just in this small project, reduce the CI by 15 points, it can add another $210,000 to the overall project bottom line here. And I know a couple others are going to dig into this concept in more detail. So with that, I'm going to hand it off to Jon to talk more about CHP implications.
All right, thanks, Brad. Appreciate that. I'm Jon Going. I'm the Western Regional Sales Manager for 2G Energy here in North America. 2G Energy is a engine CHP supplier, but also an engine supplier for many other product lines, and based out of Kiek, Germany. And we also have offices here in North America as well, 3 different offices that we have sales and service support out of. Our 2G engine product line consists from 60 kW up to 2.5 megawatts. And our product line that we actually designed from the ground up is actually 1,000 kW and lower. So anything above that, we have the ability to use different engine manufacturers from Yumbacher to MWM to MTU to help provide the best engine for each power node. In this product line you see here is the Aura. The Aura is our rich burn units. So that provides us a little more flexibility in terms of emissions controls in the state of California, for example. So we can easily just use a 3-way catalyst versus the Agenitor and Avis series. Those are our lean burn engine lines. So there we'll have to use an SCR system for applications like this. Go ahead, next slide. So 2G looks at 5 important design considerations when we do a project. First, obviously, is the gas. What kind of gas? Does it meet our requirements? We don't want to have humidity in it, all sorts of different things. Is it biogas? Is it propane? Is it RNG, natural gas? Whatever it is, we're very fuel flexible. And that's taken care of in the design of our products as well. Next one is the electrical. So we have all the electrical taken care of in our packages. Basically, power comes up to our generator circuit breaker. Other electrical considerations would be remote capabilities. So you can see the engine equipment remote from other location. Then jumping over to the thermal side. So thermal, you'll have hot water from the engine, or you'll have steam, or you could have chilled water as well. So you have various options available for applications. And then civil. So this engine equipment is designed for ease of use in a civil aspect. So basically low cost, just set it on a concrete pad and you're good to go. Emissions, like I mentioned before, we have various emission equipment capabilities. 2G actually provides their own SCR packages as well as 3-way catalysts. So we integrate that right into our engine package. A little bit different than any other packagers out there. Go ahead, next slide. Just some of the examples of different customers we've worked with in North America here. Go ahead, next. Why CHP? Well, CHP is the best benefit for you when you need heat and you need power on a site. So we can provide a great efficiency because you're not only utilizing the gas for, say, 40% electrical efficiency, but you're also using 40% for thermal needs, maybe 45%, 50%. So you end up being about 90% efficient, which is the reason why we're talking this carbon intensity score. We're actually reducing that carbon intensity by utilizing CHP on site for your projects. Offsetting utility costs, that's another important thing where not only are we lowering your CI, but we're also just taking care of your lowering your power needs on site, those high costs from the utilities. You're producing your own power. And then you're also producing your own thermal, as mentioned before. So that helps the bottom line. Finally, or other things, sustainability, we're reducing your CO2 emissions versus a standard coal facility, for example, in the Midwest. So there's much greater reductions in CO2 capabilities there versus maybe a California project where they have more solar and so on. But then we jump back to the reliability. So this kind of a system will provide reliability to projects because it'll provide on-site power needs in case of a power outage. It can also provide some flexibility on gas usage. So you can be flexible on different types of gas streams you want to bring into the gas engine itself. So go ahead, next slide, please. So CHP in an RNG setting, it's a great fit, not only because of the heat and power needs. Obviously, you need hot water for digesters. That's creating this digester gas that you're going to be utilizing into RNG. So typically, we're not going to be running on RNG. We're actually going to be running on some other fuel source, natural gas, propane, so on, because that RNG value is much higher than what your gas is that's going to be used in a CHP system. Now, as far as the CI score, as mentioned earlier, yes, we're going to help reduce that CI score, which in itself can help pay for the equipment purchase of the CHP units. Go ahead, next slide. An example of one such project in California is the Realto Bioenergy facility. Here it's using multiple 2G engines at various sizes, totaling just around 4.6 megawatts in size. They are currently taking food waste that would otherwise go to a landfill and providing power, but then they're also now producing their own RNG and selling that to SoCal Gas. These engines are also dual fuel capable, so they can run on biogas or natural gas, depending on how they want to run the facility at any one time. And it's also fully island capable. So with any of the power outages that you've heard of in California, this plant does have the capability of running off grid. Go ahead, next slide. Energia, so that project is actually owned by Energia. Energia is looking at, one of their fortes is going after municipal solid waste companies and offsetting that food waste. And that's what they're doing here. And so in this case, they bring it into an anaerobic digester. That digester produces methane. We clean that methane, put it into our gensets. That heat goes back up to the anaerobic digester. But then we're also providing power to the grid or offsetting the local power needs. And then finally, that exhaust heat and other heats can be used on site to help dry biosolids. That's another important step in this. So that biosolids is another revenue stream for these plants. Go ahead, next slide. So an example of a CHP running at a RNG facility, if we assumed a 10 CI point reduction in an RNG facility running with LCFS credits and a value of roughly $2.10 per MMBTU, that's our set point or basis, then we have an RNG facility, say roughly 530 MMBTUs per day. We would select 2 of our 500 plus engines. These are 2G engines, providing a total of 1.1 megawatts in size. That's also providing, again, energy and heat. That equipment cost is roughly 1.3, 1.4 million, and that value right there with a 10 CI point reduction correlates to about $400,000 per year on this project. Now that 10 CI point is interchangeable. It all depends on what the local grid is like, how dirty that power is. But a 10 is a good average anticipated number. I believe Ethan will be talking a little bit later where they're actually much higher on the CI points, and he can explain how he does that. So for this example, you can see here we're about 3.26 years for that payback on just the value of the CI reduction. That doesn't include, your offset costs for the electricity and the thermal energy as well. So reducing that even further. Go ahead. And I'm going to leave you with this one last thing. 2G is the first in the industry to commercially have a proven 100% hydrogen CHP system in the marketplace. So this can provide a lot of flexibility to customers that we're talking to different types of fuels that could be used. Even now, 100% green hydrogen can be utilized in our gas engines. Our current natural gas engines, as we sell into the marketplace, can be converted over to 100% hydrogen as well. So it'll provide you even more flexibility for your projects as they grow and as hydrogen becomes more and more readily available in the marketplace. We even have some customers that are even looking at creating their own hydrogen right on site. So that's another revenue source, if you will, for these projects. Okay. Next slide, I think that's it. And with that, I am finished, and I'm going to hand this off over to Ethan.
Hey, thanks for that, Jon. Apologies, everyone. I've had some internet issues here, and the webcam was pixelating and slowing things down, so I'll just do audio only to keep everybody happy and easy. So as Jon said, I'm Ethan, managing partner at the Renewable Organics Management Group of companies. We develop and install AD systems, mostly on farms, but also deal with and food waste application. We started as a pure engineering firm, which was CH4 Biogas, founded by my partner, Benjamin Strahler. And from there, moved on to being developers, standalone developers, as well as operators of the systems that we install. You can just go to the next slide, Elska. So we do the anaerobic digestion process pretty typically on a farm, where we take the cow manure from the barns, clean it up a little bit to try to get the sand and grit and other particulate out of it, and funnel that into a mesophilic anaerobic digester. The outputs obviously is renewable natural gas, as well as the high value byproducts, which are fertilizers and soil amendments for the farms and for regional agriculture industry operators. And the major benefits for the farm, in addition to being leases and having revenue from the system, is a substantial reduction in the greenhouse gas emission from their lagoons, which especially in California and a few other markets is a hot button issue in the coming years for dairies to manage their emissions from their lagoons when they go anaerobic or having long-term manure storage. Next slide. So one of the biggest problems with building biogas facilities on farms is they usually are not in the easiest area for having services and having the power that's required to put these facilities in. That the number of issues. One of the big ones is just dealing with the local utility companies and having to work with them on the time schedule and on the cost associated with upgrading the service to these farms. It can be quite lengthy, if even possible, and generally is one of the major reasons that these projects take so long and sometimes get derailed wholesale. Just an ability to get adequate service from a power and gas perspective. As aware, the bulk of farms are going to be large, they're going to be more rural. And being able to have combined heat and power as the source of both electricity and heat rather is a major benefit to being able to move these projects in a reasonable time frame and not having to deal with your upgrades to the system, or in a case very specifically here in Northern California, dealing with PG and E is a very difficult process in the best of times, and especially these days where they are having some major difficulties based on their contributing to fires over the past few years. Natural gas is often not even available at these sites, and so when you look at having a substantial heat load, you would have to use quite a lot of natural gas and have a decent amount of on-site storage if you don't have a CHP that can provide the heat off of the cooling. Next slide. So the solution that we've used in our project over the years has been to have CHP for the power and for the heat supply. They're also quite efficient at managing the loads of the system. There are a lot of moving parts to the biogas facilities and don't all require having power at the same time. So having the ability to run a series of CHPs and use the power as needed and where is needed is a major benefit to operating costs and to structuring these things. The thermal recovery, as stated, is a huge benefit because these are very heat-intensive systems. And generally, when you look at the balance between the amount of electricity required and the amount of heat required, the CHP systems generally produce the heat that's necessary for these things to run efficiently. The ability to have additional heat sources put on there, whether that's for drying of bedding or other thermals on the farm, is another benefit that we share with the farmers and with the system operators needed. And another interesting aspect, as I mentioned, there's a lot of difficulty for these farms to have their services upgraded in general. And because of that, they are sometimes limited on what they actually would like to do at their properties, whether that's installing a small processing plant or drying bedding or any number of other uses. They are able to have us provide additional power to the farm via these kind of microgrid systems, where the AD may take 1.5 megawatts of power to run. We can put on additions and have the ability to the farm's milking boiler or something else that they want to upgrade that they don't have to use the local utility service for. Another interesting aspect to this as a power generation kind of standalone entity is that while it can be owned by the project, it can also be owned by a separate entity, whether that is the farm or a small power provider, which delineates some interesting aspects when it comes to investment and generating investment tax credits and doing things related to RECs from generating electricity and selling to the biogas system into the farm. Next slide. As Jon and Brad mentioned, the carbon intensity score is a major driver in why we do these projects on dairy farms and why these projects are very profitable in the current market. So getting the enhancement for anywhere between 10 and 30 points or 50 points, depending on the sources that would be used, had you not had a CHP, be quite a dramatic number when the CI is annually reviewed. The integration with solar, which we are doing in a couple of instances where we have the solar that is previously installed at a farm or that will be installed in parallel with a digester system by the farm, is able to through the system, the digester, which gives you an even larger enhancement on your CI score. The calculations have to do, as Brad mentioned, a lot with the fuel that you're using. And so natural gas is a clean fuel. The sun providing solar power gives you an even better enhancement. The time savings can't be emphasized enough. There's numerous instances in the digester world where utilities have failed to meet deadlines and sites have been left without power, without adequate utilities in a number of instances. And so the surety of having available and the regularity of being able to maintain your own power supply is comforting when it looks at the long-term risk mitigation for these systems. Another interesting aspect that has come up just recently in the last year or so, we have a natural gas supplier that has gas that doesn't quite meet the pipeline standards at an old well of theirs, but it does meet the standards for 2G to be able to burn the engines. And so being able to use that gas, which is regionally produced, has a number of benefits besides the fact that that gas is generally discounted from your standard natural gas pricing, is a interesting quality that 2G specifically brings to the table with the flexibility on the fuel. And just one more kind of thing that we've been doing when it comes to planning for potential issues, provide that for whatever reason you're able to inject or trailer off your gas, or that gas after an upgrader doesn't quite meet the specifications that you need for your pipeline standards. There is a on-site storage, obviously, for the CHP system, and that quote-unquote off-spec RNG that you produce can be used in the 2G engines as well, as opposed to just going to the flare. So not an ideal situation when it comes to the economics. You want to sell your gas; it's very valuable. But the worst case scenario is when you're just flaring your gas and you spend all this money to process it and you're burning it off. So the ability to at least offset your cost of purchasing gas for the CHPs is a nice benefit. And from a regulatory perspective, the air boards and other county regulators like to see the flare use as little as possible. The ability to use off-spec RNG for the CHPs as a further mitigation, it really enables you to accurately say that you're use the flare except for emergency purposes. Next slide. So this is just an example of a system we're building in Northern California. This system will process about 1,000 tons of manure a day, and it produces a little over 500 MMBTU daily of RNG. The little green circle in the middle is the CHP system. So it takes a very little space with regards to the overall project size. And we generally like to place them to the heat sources, heat loads. That way we are able to efficiently use the heat without losing too much because of distances. So it's generally placed next to the digester. I go on to the next slide, Elspeth. It's the one that makes the most difference in these things. So this is the digester in Northern California. This is the enhancement and improvement compared with using grid power to using renewable energy, which is a combination of both solar and CHP power, mostly CHP. Think about 80–90% CHP power. And so you see an overall enhancement of almost 6,000 LCFS credits here. You know, there's a lot of debate about where that pricing goes in the next few years, but as it ends today, system size that we're building, that's an additional $1 million a year in additional revenue to purchasing grid power for the system. So as Jon said, you can see a pretty quick payback on the equipment that you actually have to purchase for these systems. And you can see a major enhancement long-term on the revenue side. I think there's an easy case made to say that no matter what the credit situation looks like or what model they're using, it will always be more profitable to be using renewable source for a digester project than to use grid power. So that's just kind of the high-level overview of and very kind of simple what we look at CHPs for these products and why we like them. I think the economic case, you know, once it's put in black and white, it's a pretty easy decision for everybody to make when it comes to developing these systems. And overall, you know, it's something that we will be doing on most of our sites going forward. I think that's all that I have to say on this one. I'll pass it off to Jeff.
All right, thank you, Ethan. EPC stands for Engineer, Procure, Construct, and everyone's asking for an EPC Rap. So I'm going to attempt to wrap this all together at the end of this webinar today. And we're going to focus on the development of the RNG project and really focus on budget development. And Symbiont is uniquely qualified for this task because we consist of a 100-person engineering firm and a general contractor, and together, operating as one team, we can provide that complete wrap on a project. And one of the first stages of project development is developing the budget so people can understand the business pro forma of the project. So taking in what we just learned about the value of the RNG and the operating costs, the missing piece of that puzzle is the capital cost to help determine the return on investment. So one of the most common questions I field is, hey, what is the level of accuracy for your budget? And the easiest way to describe that is by looking at an image, maybe rather than going through a lot of text. And looking at this, basically it's a funnel of the project development, starting on the left, going towards the right. And it is obvious that as you refine the project and develop the project, your cost estimate becomes more accurate. So this is a really good description of those levels of development and the accuracy of the budgetary estimate. And I think it's important to note here that the scale above and below the line it's not a mirror image. There is a difference between the plus and minus. When people are asking for the plus or minus accuracy, the plus is different than the negative, oftentimes because of things that are being missed from the cost estimates or the project development at different stages of development. Next. To expand on that graphic just a bit, we've listed here the means of what our group would do to help develop budgetary estimates. And starting at the least amount of information, we would be using a historical estimate, looking at similar projects that have similar scale to develop a true back of the napkin. So that would be starting at the top. And then as more information becomes available, you can actually do estimating and do takeoffs, and that gets to the more defined, more detailed level of an estimate, which obviously becomes much more accurate. Next. So it's important to understand the engineering design task and steps that are needed to continuously refine and develop that project. So here we've listed some of those tasks as you work through and develop the project. And some of the typical levels or milestones that we do here at Symbiont would be along the class 3 level, and that would be what we would call a design to a guaranteed maximum price. And then getting all the way down to a class 1, which is really a issue for construction package of drawings and specs and equipment information that you could go ahead and actually hard bid and build a project with. Next. So doing those tasks that were just mentioned, takes time, and time is money, right? To hire professionals to do that. So just to give you a perspective of what those costs would look like, going back to what Brad had mentioned on, I believe, a 4,000 head dairy manure project with a capex about $15 million for the full EPC Rap on a greenfield site like that. The first phase of conceptual design that would help give an indication on the project pro forma would be in that $30,000 to $50,000 range. And then the next step, which would be that 30 to 40% design completion to get to a guaranteed maximum price would be about $150,000 to $200,000. And that would typically take about 8 weeks of time to develop all that information to get to that level of accuracy. And then by the time you're ready to construct, you've completed more engineering design, site testing and whatnot, and you can expect to spend up to 5 to 10% of the total project cost on professional service fees to get to project completion. So that just gives you an idea when you're developing a budget and for project development and actually for execution, what those costs would be and what that timing would take. Next. So we would break down our pricing by category of work. And we do that by services, we do that by the type of construction, we do that for the equipment, and that would be a line by line item project estimate budget that we would develop. And the important thing to note with this is the right column here, and that's contingency that we're listing there. And I had a definition of what contingency means, and a lot of people just say it's unknowns, which is partially true, but it's really for unknown but expected is really what contingency represents. And it's important to look at how we're doing this on this table here. We're assigning different contingencies to different line items based upon what we know and what we have not completed yet as far as the amount of work for each specific line item. So that could be, maybe the number of bids we got from a specific subcontracting task. Maybe we only were able to get 1 or 2 versus the 3 to 5. So that would maybe say, hey, we should hold more contingency on that because we didn't get adequate responses from local contractors that are familiar with the site and the type of work we're doing, versus adding a contingency to the overall total project cost and just putting a lump sum on the overall project. This is a much more accurate way of developing budgets. And then as you continue to define and get more information in, you can refine and remove or reduce the level of contingency on a line item, so you can show the development of the project by showing different cost estimates at different times and upgrading the contingency accordingly to the information you have. Next. And it's really important to define the roles of a project when you're putting a cost estimate together, specifically for as the EPC. We're being asked to wrap it, but there's still some items that are not specific to the EPC, such as what an owner, an operator, other parties involved may be doing on the project. And this roles and responsibility matrix we develop for every single project, and it really helps understand who is doing what. And oftentimes this will get attached to a contract. Financiers want to see this as well to say what is your EPC really doing. And instead of having a lot of emails going around, it's really nice to summarize this in a single document that everyone has access to, and you continue to update by adding comments in the column to the right. Next. And then to support the cost estimate, there's just a lot of information that we would need to use to kind of bookend the cost estimate. And that we do that by developing site-specific assumptions and exclusions that each project's budget is based upon. A good example of that would be site conditions, such as the soil conditions or groundwater, which can impact, foundations. All the equipment we've been talking about today, whether it be a digester or a CHP, has a substantial bearing requirement for the foundation, and based upon where you're at in the country with seismic issues or weather and frost issues, that can be a pretty significant impact to the overall cost. So that's just one example that we would outline here in our assumptions and exclusions, but we do that for all components of the project to really bookend the budget. And once again, these can be changed as more information becomes available, such as doing geotech borings for the site. That would help reduce the assumptions or exclusions for geotech, since there wasn't any provided at the time. So then you can hone in on your cost estimate by doing that type of work. Next. So just to kind of wrap this up as the EPC Rap, we really wanted to make people understand the time and cost that goes along that time to develop budgets, the level of accuracy as you continue to develop the projects, and most recently, just to give everybody an update that if we were to go back right now and look at a project we did 18 months ago, and we were trying to duplicate that project today, due to the market conditions that hopefully we're all familiar with, there's a substantial change in cost and schedule to do the exact same project. So it's important to get a good understanding of the market conditions with your subcontractors, your equipment vendors, and your EPC to make sure when you're going to finalize your project budgets, you have representative costs, and that'll make a project much more successful. That concludes the EPC portion of our webinar. I'll turn it back to you.
All right, I'll hop in here with a few questions. I know we're running out of time, but we have a few questions, and we can play this out as people leave. First question I have, not sure who's best suited to answer it, but if the perhaps Brad or Ethan want to jump in on this one. The first question we have, if I could get this up here correctly, is a key source of fossil natural gas emissions is the wellhead and transport fugitive methane emissions. When we displace natural gas with RNG in a local gas utilities distribution network, one would presume there is an associated avoided emissions. Does the GREET model account for this avoided emissions?
I can certainly, this is Brad, I'll certainly take a stab at it. I think the GREET model can account for that at wellhead emissions. In the California LCFS and most other programs that use a CI-based system, they've simplified the GREET model, the calculator, to make it a little bit more user-friendly. And I think that usually don't go that far back into the process. So North American natural gas and the California GREET all has the same CI score. So you're not getting the benefit of a local gas utility or localized wellhead reduction emissions. Same thing on the electricity side. The electricity grid is broken up into regions. So even if my local utility here is using a lot of wind and solar, I'm still going to be bound by using the region grid mix. But that does play into things. So like in the upper Midwest, the electricity grid's a little dirtier than say in California, where there's a lot of renewables, other areas where there's a lot of hydro. So there in the electricity side, there's a little bit more difference, but generally on the natural gas side, the model is using a fixed carbon intensity number for that. So you don't get that benefit, but you can calculate it through the model.
That's great, thanks, Brad. The models are very complex. We're glad to have you here to sort through it for us. While we're on you for questions, you mentioned D3 RINs in your talk. Can you explain the difference between D3 and D5 RINs?
Yeah, I'm glad somebody brought that up. I didn't clarify that very well. But so in RNG, under the RFS, every feedstock type and fuel type has a different RIN called a D code. And there's several, 5 or 6 common D codes of RINs. With RNG as a fuel, a transportation fuel, you can qualify, there's pathways for a D3 and a D5 RIN. The D3 is a cellulosic-based RIN that's generated from a cellulosic-based fuel feedstock. So animal manures, ag residues, landfill gas, wastewater treatment plant biosolids, or any other feedstock that has a 75% or greater adjusted cellulose content, separated MSW being another one that's in the regulation. If you can qualify for that, you'll get the D3 RIN. And if you're not that, if you're really anything else, as long as it's renewable biomass, then you would generate a D5 RIN. And so the two have different values. So right now the D3 RIN is somewhere around $3.15 per RIN, and a D5 RIN is around $1.85, $1.90. But that gap and that spread has been higher in the past, up to 4 or 5x difference. So a lot of people are targeting those cellulosic feedstocks in order to capitalize on the higher value D3 RIN.
Thanks, Brad. Jon, we have a couple questions for you. First one is, are 2G systems able to dynamically blend between biogas and natural gas?
Yes, they can. So they can use, say for instance, they're running on biogas and running 100% on biogas, and the level of the digester starts dropping, they can automatically start blending in natural gas as needed to maintain 100% power output. So yes, either 0 to 100% on either fuel is, in a blend thereof is available on our engines. And that also would also include hydrogen as well.
One more question for you. In the absence of an LCFS credit, can you summarize the benefits of CHP economically at an RNG facility?
Yeah, so you would still have the benefits of CHP in general. So you'll still have electricity and heat that you're going to be able to offset from the utility. You won't have the credits anymore because the LCFS is not being considered. However, you're still taking down, what, 10-cent kilowatt, power. You're reducing your natural gas costs because you're not putting it into a boiler. So you do have that flexibility of a typical CHP application is still there.
Great, thank you. For Ethan, what size farm is the smallest for an economically viable project in your view?
So there's a lot of factors that go into that, and it depends on your particular tolerance for the risk. If you want today's pricing, you're going to be able to do, things in the range of 3,000 to 4,000 cows and that kind of a small operation. But if you're a little more conservative on your outlook, we find that after around 7,000 to 9,000 cows of total material, you're in a very easy situation to be able to handle, as Jeff mentioned, the exorbitant cost of construction these days. That we build systems continuously year after year, and the price difference between today's costs and just a couple of years ago is quite staggering. So with those, it's a little more difficult to fit the small project into the economically viable category.
Okay, great, thank you. One more question for the panel at large. How do projects overcome the challenge that LCFS credits are not awarded until after the project is constructed? How do project developers get their heads around that risk? I believe that came up in Brad, your presentation, that the LCFS doesn't actually get awarded until the facility is in production.
Sure. Yeah, I can take a stab at it, and others can jump in too. But yeah, I think it's just something you have to plan for, especially through the application process. It's likely going to be, at the very best case, 6 months from commercial operations before you're going to get a registered pathway under the LCFS. More likely 9 months, and then you have to generate the credit and then sell the credit. So usually what we'll see is people banking and planning for about 10 months or so of limited LCFS cash flow. Usually the RIN is also with that because you're storing that gas. You don't lose the value while you're, while in that 10-month period. You have to do you can do some virtual storage of gas through some accounting exercises. But it is an issue that, in order to fully monetize, you're going to have to wait that long. The LCFS also has a process where you can use a temporary pathway, and you can generate credits basically after you submit the application. And that temporary pathway, though, is a -150 for dairy and swine manure. So if your CI score of your project is -250, -300, you're going to be leaving a lot of revenue potential on the table by utilizing that temporary score. But if you're closer to that -150 number, there's less of a financial impact. So it's really just an economic exercise of what makes the most sense, and analyze, does that temporary pathway score work for your project? Otherwise, just planning and budgeting for that 9-10 months is good practice.
So there's no real risk that you don't receive the LCFS credit. It's just a timing risk on the revenue.
I think it's more of a timing risk. I think it could be, if you're doing something very, very unique or innovative in your project, what we'd recommend is approaching CARB, the Air Resources Board, ahead of time and walking them through that so you don't get any surprises after you submit your application. But in general, as long as you're following, your RNG at a dairy farm, and there's many, many other projects that have gone before you, it's usually not too much of a risk, unless you're doing something unique there.
Great, thank you. Jon, you mentioned hydrogen in your presentation. This is a question for the group at large. How do we see hydrogen and RNG playing together in the renewable fuel market in the medium term?
When we are considering the hydrogen, at least for our side of the equation, we're considering it obviously for offsetting power and heat at the facilities. Hydrogen as a transportation fuel, I think that kind of goes to what Brad was saying earlier, where it doesn't necessarily matter what the fuel end source is. Those LCFS credits are available, and they're calculated the same way. But yeah, it's definitely a fuel source that we're able to utilize on these projects, much like any of the other gases that are available for us. So I don't know if, Brad, you have any further comment to that?
No, I think that's right on, Jon. I think if you're using it as transportation fuel, maybe the one downside is you don't get the RIN. Right now, there's no approved RFS pathway for hydrogen as a transportation fuel. I think some people are pushing, to get that as an approved pathway. So in that case, if you're producing hydrogen, then you're only going to be limited to the LCFS program. But the other thing too is, not to get too far in the weeds, but you can still generate RNG, inject that into the grid, and then at a hydrogen production facility, you can use that same book and claim or contractual contract to make renewable hydrogen. You don't necessarily have to produce it at your site and transport it into California. So RNG oftentimes allows for that flexibility that, unless a utility, I don't know of anyone that's making hydrogen and putting it into the grid like a utility grid. That's a really emerging and hot topic within the industry, but I think that's still in the really, really early stages. And by generating RNG, you can capture a lot of the same benefits of producing renewable hydrogen, especially through like the SMR process, from renewable natural gas, renewable electricity, and capture some of the similar benefits, but not have that complexity at your project site.
One last question for Jeff. What percentage of projects that you work on include CHP in their RNG facility versus exclude it?
So I'm not sure about the percentages. I'm not that great with math, but we try to wrap it in with all our projects, right? So to show that added value, so it's not necessarily the CapEx. It's like this whole presentation, what we're looking at is the overall financial performance of the project. So it's included in most of our projects as initial CapEx, but there's other factors that come into play, such as air emissions and air permitting on projects that have to take into account on every single specific project site. So we try to wrap it in every time because of the benefit it has to the CI score.
Great. That's it for questions on the list. Elska, I don't know if we have any ad hoc discussion, but I'll turn my camera off and thank you everybody for the time.
Okay, great. Thank you, Kurt. Wow, that hour and a bit really flew by. That was great. Thank you all to the panelists for sharing your knowledge today, and thank you all the attendees for joining us today as well. We hope you found the webinar beneficial and that you learned something. We will be sending out a follow-up email after the event this afternoon. It will contain everybody's contact information, of course. So if you have any more questions, or tomorrow morning in the shower, you go, oh my goodness, I wish I'd asked that, you can certainly email the panelists and follow up with them. They'd be happy to help you. So once again, thank you so much for joining us, and enjoy the rest of your day. Thank you so much.